This is a review for Business Finance Test 1. So the first question, just the problems. For the multiple choice, the conceptual multiple choice, you want to look at the review sheet and kind of map that out from your textbook. So for the problems, which will also, some of them, most of them will be multiple choice, some of them will be actual problems, but anything that's a computational multiple choice is worth at least 5 points, could be 7.5 points, depending on the amount of work that you have to do. So the first one we have, if the college wants to give a $450 scholarship each year forever, and the annual interest rate is 6%, what is the present value? So for this one, even though it uses the term present value, we're not using our time value of money keys. It's just a straight formula where we take our $450 and we divide that by the 6% or the 0.06. And that gives us $7,500. So that is your present value. Okay, then down here we have, let's see if I can move this. Then down here we have, understand the difference between the nominal stated rate and the effective rate, and then compute the effective rate of the following. So PNC Bank lends funds at 8% with quarterly payments. Key Bank wants to match PNC's effective rate but requires monthly payments. So then what is their nominal interest rate? So we're going to use our second menu. Oops. Second menu, and then the number 2. That takes us into the interest conversion function. Sorry that I'm opening these different little boxes. Let me try to get it set up. Okay. And then once you open that up, so your second menu, the icon V, the first field is your NOM. And then in this case, it's going to be 8 and hit enter. Then if you arrow down to the next field you come to is the EFF. So arrow down until you get to the C/Y, which is our compounding periods per year. And then if it's quarterly, it's 4. So push 4 and enter. Then we're going to arrow back up to that EFF field and push compute. And that gives us 8.24. So that is our effective rate. So then if Key Bank wants to match that and they do monthly payments, we'll come down here. Let me see, I guess if I can move it up a little bit. So again, we'll go into that same function, but now our NOM is going to be what we're looking for. So I guess I'll start with our EFF. So our EFF is going to be the 8.24. The compounding periods per year is going to be 12 because it's monthly. And then we're going to arrow back up to that nominal rate and then push compute. So I guess I said it over here, but I didn't type it. Over on this one, you would have computed on that EFF field. Okay, so then when I come to my calculator, the nominal rate's what we're looking for. The EFF is 8.24, push enter. Arrow down, make that compounding periods per year 12, push enter. And then you can arrow down or arrow twice back up. Just get back to that NOM field and then push compute. And it is 7.94. So then their nominal or stated rate would have to be 7.94 to have the same rate as the PNC Bank does. Okay, so then those are our first 2. Let me move over here and get to our next 2. I I guess I'll just do one at a time here. So you need $16,000 to buy a car, and you're going to make quarterly payments for 5 years. So compute that payment and then how much principal and interest comes out of the first payment. So again, I'll put in a text box here. Whoops. I'd like it to go up so I got plenty of space. Okay, so put it there. All right, so again, we're going to go to our time value money keys. So if we're making quarterly payments times 5 years, that's going to be 20 as our N. Then I don't have a rate in there, do I? Let me go back over. Did it copy everything? All right. Let's make that 8%. So then if it's 8% per year divided by quarterly, that's going to be 2 as our IY. 16,000, hit your plus or minus button to make it negative is your PV. Zero out your future value because it's a loan. So when it's, by the time you make all your payments, it's paid off. And then compute your PMT. So again, if I come to my calculator, 20 is my N, 2 is my IY, 16,000 is my present value, no future value, compute the payment, it's $978.51. Okay, then I'm going to come over and say, okay, now I want to not do that. Now I want to amortize it. So I'm going to put that over here. So to amortize it, don't clear out your tables, hit your second menu button, and then your PV, and that will take you into the amortization function. So then you're going to want, if they want to know how much comes out of payment 1, you're going to want your P1 to be 1 and push enter. You're going to want your P2 to also be 1 and then push enter. And then you're going to fill in. So it gives us a balance. And then what it says is the loan balance goes down to $15,341.49. The principal that comes out of that first quarterly payment is $658.51. And then the interest is $320. So then that would be how we solve that one. Okay, then we'll come back over to number 4. Here. Okay. So we've got find your present values of the uneven cash flow streams at a 10% discount rate. So, whoops, maybe let me go out a little bit if it'll, because we want to have all 5 years in there. Okay. So for years 1, 2, 3, 4, and 5, what if the present discount rate is 0? So we got to do it 2 ways. So the 0 way is easy. So the first thing says, what if it's at 10%? So then that's where we'll start. Oops. So let me move this over if I can. Okay. So then we're going to say our cash flow for number 1, stream 1. We're going to hit our cash flow button. The first field is our cash flow for year 0, and that is 0. And if you have a value in there, you'll have to push enter. So 0 and enter. Then your cash flow for year 1 is going to be 100. Whoops. Hit enter. Then your frequency for that is going to be a 1. And it should default to that unless you had another value in there. If there is a value, go over it with the 1. Then your second cash flow is 250. Push enter. Frequency of 1. Your third cash flow is 350. Push enter. That frequency is also a 1. Your fourth cash flow is 450. Push enter. That frequency is a 1. And then your fifth cash flow is 500. Push enter. And then that is also a 1. So again, you'll put that all directly into your calculator. Okay, so now I have that into my calculator. Then we're going to come over and then we're going to push. I don't know why it does this to me. I push the wrong buttons and it goes crazy. Okay, so let me get this up here. Okay, then we're going to push our net present value button. We're going to have I equal to 10 and push enter. Arrow down and then push compute. And that gives us $1,178.30. Okay, then we'll do the same thing for the cash flow for for stream 2. So my cash flow for year 0 is 0 with that stream 2 as well. Okay, then the cash flow for year 1 is 250. That 2 is a frequency of 1. Cash flow for year 2 is 300. Whoops. And that frequency is a 1. The cash flow for year 3 is 400. And that is a frequency of 1. The cash flow for year 4 is 250. And that is a frequency of 1. Whoops, I got too many F's up there. Okay, then the cash flow for year 5 is 450. And then that is a frequency of 1. Okay, so then we'll put that into our calculator. Okay, so I got that all in. Then we'll come over and then we'll hit our net present value button. Our I is still going to be equal to 10. Come down to the net present value and then push compute. And we get $1,225.90. So then the second cash flow has the higher net present value. When you do it at 0, so if I go back to answer that, at 0%, it's just adding those cash flows. So 100 plus 250 plus 350 plus 450 plus 500 gives us 1650. And then 250 plus 300. Sorry, plus 400 plus 250 plus 450, that also gives us 1650. So if there's no discount rate, you just add them straight across. And I think what the point of this is trying to show us is it's the exact same amount of money coming in stream 1 and stream 2. It's just at different increments. So stream 2 is more favorable because you get higher dollar amounts at the beginning. So then that is that one. Okay, so then we'll clear that. Then going back over to our review sheet, we've got Julie just graduated from college, and then she's going to save for retirement. Okay, and again, it doesn't have to be quite so big. I'd like to make it a little smaller. I'm struggling to do that. Okay, so we'll just see if I can't leave it that big. Okay, so she just graduated from college. She's 24. She's going to be saving $5,000 at the end of the year, end of each year. So how much money will she have when she is 65? Okay, so we'll bring this up. So if she's 24 right now and she's going to save until she's 65, that gives her 41 years to save. So that's our N. The rate on this one also. All right, so we'll make this 8% as well. So so 8% is our IY. She's saving, she's not starting with anything now, but she's saving $5,000 each year. So that's our payment. And then we're going to compute the future value. So we'll put that into our calculator. 41 is the N, 8 is the IY, 0 out the present value, $5,000 payment, and then compute the future value. So she would end up with $1,403,905. What if she lived to be or how much would she have if she saved until she was 70? So that'd be 5 more years. So if you don't clear out your work, just make your N 46 and then recompute your future value. And then you'll get 2,092,130. So she could make quite a bit more or save just quite a bit more if she works those additional 5 years. Okay, then we move on to the second step. So the second step says, okay, now if she expects to live until she's 85, how much could she withdraw if she retires at 65? And then how much could she withdraw if she retires at 70? So now we're going the other direction. So if she retires at 65 and she expects to live to be 85, that will be 20 years in retirement. We're going to leave the IY at the 8. We're trying to figure out the payment. So what we've calculated over here is our present value, because it's our present value of retirement. That's how much money she'll have the day she retires. The day she dies, our future value, it can be 0, because she's not trying to save money past death. So 85 is death and that future value is 0. And then we'll compute the payment. Okay, so then coming back, 20 is our N, 8's our IY, $1,403,905. Make that negative by hitting the plus or minus button. Slide that in there. Is our present value. Zero out that future value and compute the payment. She could be able to withdraw $142,991 if I round it to the nearest dollar. So that is an awesome retirement. Okay, then we'll go down and say, okay, well, what about, what if she retires at 70? So then we've got that larger amount, and then she lives not as long. So there'll be 15 years then till she's 85. Still 8 as our IY. Then now this becomes our new present value. Zero out the future value, because again, that's when she's going to die, so she doesn't need to have money. And then we'll compute that payment. So she's probably going to have a ton of money if she would actually wait that long. So that would be $244,423 if I round it. So obviously she is going to be just fine if she starts saving that long and she works that long. Okay, so then that is our chapter 5. So I will break this video into sections. So that completes the chapter 5. Okay, so this is review for Business Finance Test 1, Chapter 7. So our first problem says we have a $1,000 10-year bond that is issued at 7% interest and pays interest semi-annually. The current yield rate is 5%. What will the bond sell for today? So again, we're going to go to our time value money keys. It's 10 years and it's semi-annually, so we multiply by 2, and that gives us 20 semi-annual periods. The yield rate is 5%. We divide that by 2, and that gives us 2.5% IY. They pay 7% a year, but then it's going to go in semi-annual payments. So it's $70 annually. We need to divide that by 2 also to have a $35 payment. Sorry, this is not correct. Computed yet. So we've got 20 as our N, 2.5 as the IY. We have a $35 payment that we're getting each 6 months, $1,000 back at the end, and then we'll compute the present value. So $1,155.89. So it is selling at a premium. So it's over $1,000, and the reason it's selling at a premium is because these bonds are paying 7% when all the other bonds in the market are paying 5%. So everyone's going to want these higher interest bonds, which is going to push the price up. Okay, then we'll come down to our next one. So we have now compute the yield to maturity rate on the following 2 bonds. So we have a 5-year bond that has a $1,000 par value, a coupon rate of 7%, and a current market price of $875. So our N is going to be 5. We're trying to figure out the IY. We're computing the yield to maturity, so we'll skip over that. Our present value is the current market price. So that is $875. We'll make it negative by hitting the plus or minus button. Again, it's the same as above. It pays a 7% coupon. So as I calculated up here, 7% times the $1,000 gives us $70 a year. Now in this case, it's annual payments, so we don't have to divide that by 2. We have a $1,000 future value, and then now we'll compute the IY. And notice that my payment and my future value are both positive and my present value is negative. So 5 is my N, 875 negative is my present value. 70 is my payment. $1,000 future value. And then compute the IY. And that gives me 10.32. So these bonds in this example are selling at a discount, which tells us that they must be paying a lower rate of interest than all the other bonds in the market. So it would make sense then that the IY of 10.32 is higher than the 7%. Okay, then we'll do one more. I don't know why it does. Sometimes it doesn't let me drag that. I don't want to type it there. I want to type it here. Okay. So we've got 5-year bonds with $1,000 par and a coupon rate of 6% with a market rate of 1,152. So our N is still 5. Our present value now is 1,152. Again, hit your plus or minus button to make it negative. The payment is 6%, so that would be 0.06 times the $1,000, which gives us $60 as our PMT. Okay, then we'll come down and still have $1,000 future value, and then we'll compute the IY. So 5 is our N, 1,152, hit the plus or minus button, is our PV. $60 payment, $1,000 future value, and then compute the IY. Let me do that one more time. So that gives me 2.71%. Which seems very low to me, but I guess that would stand to be the truth. I mean, it's going to be lower than the 6%. So the 6% is what the bonds are paying, but they're selling at a premium. So then the current market rate has to be below the 6%. So it's the 2.71%. Okay, then we'll come over. And we've got one more for chapter 7, so I will clear this out, and then we'll copy this one over. Oops, where did it go? There it is. All right. So you're consider investing in a 20-year bond that pays 7% semi-annually. You require a 10% nominal yield rate. How much would you be willing to pay for the bond? Okay, so we'll go ahead and put that into our time value money keys. So it's 20 years, but it pays interest semi-annually. So 40 is going to be our N. We require the nominal yield rate. So that is our IY. So it's 10% a year. Divide that by 2. We would require 5% each semi-annual period. It is paying 7% annually. So again, bonds are always $1,000. So the $1,000 times the 7% is going to equal the $70, and that is our payment. Our future value is always $1,000 because bonds are always issued in $1,000 increments. So then we will compute our present value of that bond. So 40 is our N, 5 is the IY, $70 payment, $1,000 future value, compute the present value. So we would be willing to pay 1,300. Oh shoot, no, darn it. I have to divide this by 2 also because it's semi-annual. 40 is our N, 5 is the IY, 35 is my payment, $1,000 future value, and then compute the present value. So that gives us $742.61. No, and that, I don't think that's right. Let me do that again. Sorry. 40 is my N, 5 is my IY, 35 is my payment, $1,000 is my future value, and then compute the present value. 742.61. So yeah, okay, so that would be correct. It just seemed low to me. But so it would be at a discount because it is paying 7% interest, but we would require a 10% yield so that we would not be willing to pay the whole $1,000. We would expect it to be at a discount because what we need to make is higher than what they are currently paying. So that's the most that we would be willing to pay for that bond. All right, so this is Business Finance Test 1, test review for Chapter 8. So Chapter 8, we're using our CAPM formula. So if our T-bill rate is 2.5% and the market rate is 7.5%, JARC Incorporated has a beta of 6.5 and Baxter Incorporated has a beta of 1.15. So how much does Baxter's required return exceed JARC's? So our CAPM formula, we're calculating our required rate of return, excuse me. Okay. And then that is going to be equal to the risk-free rate plus the beta times the market rate minus, I'd like it to minus that risk-free rate. So that's our formula. So again, we're trying to figure this required rate out. Our risk-free rate is equal to the T-bill, so that's 2.5 plus, and I'm going to leave them in whole numbers. You can convert them into decimals, but it's all percentages here, so I feel like as long as you know that, it's okay. Then our beta for the JARC is 0.65, and then we multiply that times 7.5 minus 2.5. So again, follow your math rules. We got to get rid of those parentheses first. So 7.5 minus 2.5 leaves us 5, and then 5 times 0.65 gives us 3.25. So then for JARCs, it's going to be 5.75%. Okay, then we're going to go down and do the same thing for Baxter. So the risk-free rate doesn't change. That's based on the T-bill, so that doesn't change between the companies. But what does change is the beta. So the beta measures the risk of the company itself. The rest of the formula will be the same because our market rate of interest is still the same and our risk-free rate is still the same. So again, we got to deal with the parentheses first. So 7.5 minus the 2.5 leaves us with 5. Multiply 5 times 1.15, and that gives us 5.75. So then Baxter's is going to be the 2.5 plus the 5.75. So that's 8.25%. And then if we just subtract those, it's a 2.5% difference. That's actually what it's asking for. How much does it exceed JARCs? And it exceeds it by the 2.5. And so again, this is always a measure of risk. If it's a 1, it says it's just as risky as market. If it's above 1, it's more risky. If it's below 1, it's less risky. So if it's less risky, we require a lower rate of return. If we're assuming the risk, we better get paid for it. So we require a higher rate of return. Okay. Then we come down, and that is it for chapter 8. So we'll go ahead and we will, I guess we'll come back then to chapter 9. Okay, so this is a review for business finance test 1. This is chapter 9. So West Corp just paid a dividend of 75 cents, and it expects it to increase at 8% in the next 2 years, and then 3% thereafter. Calculate the expected dividend for the next 5 years. So if it starts at 75 cents, and we expect it to increase 8%, if I multiply it by 1.08, that means it's 100% of what it was last year plus an 8% increase. So it saves us a mathematical step if we just multiply it by 108% or 1.08. So that's 0.81. Then the 0.81 is going to go up another 8%. So I can take that and multiply it by 1.08. And that takes me up to 0.875. If I round it, it's 0.8748, but I'll round it to the nearest thousandths. Okay, then we'll take that, and then now after 2 years, though, it's only going to increase 3%. So then that's going to be 1.03. So that gives me 0.901, and then that's going to go up another 3%. So then we're up to 0.928, and then finally it goes up another 3%, and then that completes our 5 years. And that I'd round to 956. Okay, so then that is our expected dividend for the next 3 years, and we can see how it grows. Okay, then we have Ajax Corporation just paid a dividend of 60 cents, and it is expected to grow at a constant rate of 6% per year. If the company has a beta of 1.3, the risk-free rate is 4%, and the return on the market is 11%. What will the current stock price be? So the formula for our current stock price, maybe I'll put it over here, and then we'll do the math. But our stock price is equal to our current dividend divided by, the required rate minus the growth rate. So that's our formula. So as we look at that, we don't have the current dividend. They just paid 60 cents, so it's going to go up by 6%. So then we're really going to have to say, if I take do what we did above, if I take the 60 cents and I multiply that by 1.06, my expected dividend So again, this current dividend isn't your past dividend, it's your upcoming one. So that would be 0.636. Then the required rate, we also don't know. So we need to calculate that as well. So I'm going to, whoops, try that again. There we go. Okay, so then it's that same formula that we just did in the last chapter, but it's going to be our risk-free rate plus the beta times the market minus the risk-free. So then we'll come down and we'll fill that in. So we don't know what that required rate is. That's what we're looking for. Our risk-free rate is the 4%. The beta is 1.3. The market rate is 11%. And then the risk-free rate is 4. So again, we got to deal with what's in the parentheses. So 11 minus 4 gives us 7 times 1.3. So that would be 4 plus 9.1. And I'm going to, just for space, I'm going to come over here. So our required rate is going to be 13.1. So then now we'll come down, see if I can move these up a little bit. And now we'll fill in this formula that I have listed out over there. So our current dividend is the 0.636. We're going to divide that by the required rate of 13.1% minus the growth rate of 6%. And then to simplify that, now when I get to this step, I'm going to put those back into decimals. So 13.1% minus 6% is 7.1%. But in order to do the math of it right, I must make sure that I put that in decimal form. Don't leave it as a whole number. Okay, so then 0.636 divided by 0.071 gives us 8.96 if I round it to the nearest dollar. So that would be how much we would be willing to pay for a share of that stock. And it's low probably because, again, it's a riskier stock with that higher beta. Okay. Then we have one more question for Chapter 9. So then let me come over here and clear this canvas. And then we'll copy that over. Make it a little bit smaller. All right, so the TR Young Company has issued $100 par preferred stock that pays an 8% annual dividend and is priced to yield 6%. So what is its price? So then our formula for that is going to be our price, our share price is going to be equal to the dividend divided by the required rate. So our dividend in this case is the $100 times the 8%. So that's $8 a share divided by a required rate, which is the 6%. So then 8 divided by 0.06 gives us $133.33. So they're selling at over par value because they are, if you're in a market that all the other preferred stocks are paying 6%, your preferred stock is paying 8%, people are going to be willing to pay more to get it. So that price would be above the par value. Okay, then the second scenario says, doesn't let me move it. It just takes it away from me. Okay, there we go. What happens to the price if the interest rate rises to 8%? Well, what's going to happen is it's going to sell at par because the stated rate equals the required rate. But I'll show you mathematically. So if we know up above it's the $8 is what it's paying, you know, the $100 times, if we look up here, the $100 times the 0.08, and then if we divide that by our new required rate of return of 8%, then you can see mathematically it's $100. But it always goes back to say what is it paying compared to what the market rate is. So if it's paying what the market rate is, it'll sell for par.